Okay, I don't think this is the case, but I'm going to ask just to be sure. But when you're doing the test in the pan, and the oil appears to contract with the surface collecting agent, is that a result of the surface collecting agent like somehow causing the oil to contract underneath itself, or is it because it's got borders to the pan that it's spreading out, and then the oil is being pushed in, squeezed in against the pan? So I'm wondering how that, if you didn't have the borders of the pan, you had a much larger body of water, and you put the surfactant around it, because the surfactant has more area that it can spread into away from the oil still push the surfactant away and not cause it to shrink?
Yeah, so the question is, does because some of the experiments that were done inside of a pan, and there's borders on that pan, would that have an effect in an open ocean? Would it have the same effect, or would the herders act differently in an open ocean environment versus in a pan environment, I guess you could say?
The answer to that, quite simply, is no. The herders do not need the walls of the pan in order to work. The mechanism for the herders themselves to spread out, they form a very, very thin monomolecular layer. The walls are somewhat irrelevant. And when I first started getting into research on it, it was kind of hard for me to wrap my head around A, how effective they were at actually doing what they were doing, and B, from a non-scientific, but gee whiz, this is really cool, to show it and demonstrate it to other people as well. Because intuitively, everyone's used to seeing oil hit water and spread out, but to have that happen and then apply a tiny, tiny bit of herder and have the oil contract is pretty amazing stuff.
I'm curious if the kind of cleanliness of the water, the sediment of the water, affects how effective the herders are. And either are the herders inhibited or blocked at all? Say there was like a large algae in the water.
It really comes down to the question was, does sediment loading or algae loading in the water affect the herder operation, performance of herders? Herders operate by changing the surface tension of the liquid at that surface interface. So it really depends on the sediment should have zero impact. Algae, because it's more of an organic compound, may start getting into it, but I don't think it would affect the surface tension of the water to a degree where it's going to show a demonstrable difference with the use of herders.
How does a surface collecting agent differ from a dispersant?
I would say that a dispersant acts when it interacts with the oil, it breaks the oil into smaller molecules and drops it into the water column, whereas a surface collecting agent produces a monomolecular layer around the oil and pushes it, and it doesn't interact so much with the oil internally, but on the edges of the oil.
Don't they both utilize surfactants to activate the chemical bond?
Do they both use surfactants to activate the chemical bond?
Yes, but I guess the
different type of surfactants.
Right. It really is a different mechanism, and the way dispersants work is they require a lot of energy to actually start breaking the oil into the smaller droplets as well. You need that energy. Herders in their action don't need the energy in order to do their work. In fact, if you start getting too high of a sea state, a general rule of thumb has been too much action in an ocean will start to disrupt the layer of the herder and its operation. Because the layer of the herder is so thin, you're going to kind of tear it apart if the water is too rough. versus a dispersant use where you want that energy in order to start breaking the oil up into smaller droplets, and the dispersant will help keep the, well, two things. One is make the, keep the droplets separate and break the oil into smaller droplets than it might otherwise be broken into.
I have a question.
Tim, you need to unmute yourself. You're muted.
I was
All right.
going to say, I'm surprised Tim hasn't jumped in here at some point.
Yeah, let me just add a couple of things. I'd say fundamentally the dispersants are made up of surfactants and the herders are made up of surfactants. They're formulated for different things, right, as David and James were saying. But you could spray a core exit 9500 around the perimeter of an oil slick and keep it off of the oil slick, and it would do the herding as well. It might not be as effective, but it might be, right? It might depend on the oil. But the fundamental difference is you spray herders onto the water surface, right? They are surfactants, and the molecule in the herders we used are surface active molecules, just like we use in herders. They're different molecules because their goal is to reduce the surface tension of the water on the perimeter of the slick. If you were going to disperse the oil slick, you'd spray the dispersant onto the oil slick itself. But what the dispersant is trying to do is reduce the interfacial and surface tension of the oil slick itself, and the herder is trying to reduce just the surface tension of the water. So fundamentally, they're trying to do the same thing, but they are different formulations because the different formulations are more effective for one job versus the other job.
Thinking about the delivery system, the Sea-Doo option, for example, if you're using that, is there a contingency for failures on that? Like if like you said, you may want to use that instead of an aircraft in some cases because it might even be quicker. But would you always have a contingency in case something happens with that technology that doesn't get to the site?
The question is there redundancy built into the system if if you have the jet ski system versus aerial system versus a vessel system? I would say, if the jet ski didn't work, you still have two backups, or at least one backup. You can do it from a vessel. So it might be a little bit slower because he's talking 50 to 60 miles an hour, where we're talking 20 to 25 miles an hour. So, you're looking at twice the amount of time to get there to do it. And it all depends on the type of spill and what the spill is actually made of, what type of oil it is. Is it going to emulsify quickly? That may have a factor in, or if it's been sitting out there for a day, it may not be an option.
Yeah, just to add to that, I'm not sure what kind of redundancy you're talking about. If you're talking about redundancy because the jet ski, went off to Timbuktu and didn't go where it was supposed to, but used two jet skis, right? If there's a mechanical failure with jet ski, I mean, the vision we have is a big vessel would have at least two of these jet skis on it, right? So you send them both out if one fails. The redundancy, if the herders don't do what you want them to do, would be you're left with the other response options of mechanical recovery or use of dispersants.
Yeah, just the way these things are considered is they are tools in the toolbox, and if one doesn't work or has a problem or fails for whatever reason, you go back to the toolbox and see what else you've got and what's most applicable for the environmental conditions you're dealing with.
Yeah, that part wasn't part of my question, but yeah, that's important.
So there are a number of online questions, and for whatever reason they're not coming up on this version of the chat. So I'll try to, yeah.
So did you already ask this question? Right? Would the herders diminish the skimmer efficiency of the prolific service of the disc?
So for our online speakers, I wasn't sure if you guys could hear that. Can you guys see the Q&A button on your Zoom screens right there, so you can see some of the online questions? But the question is whether or not the herders are going to reduce the efficiency of the disc skimmers, right? That's essentially the question.
In the research that I quickly discussed, preliminary testings that we were involved in showed that the performance was not measurably adversely affected. There was some variability in the numbers, but it's within the experimental norm. You're not going to have exact numbers from one run to the next. So,
yeah, let me just add you know, the goal is not to spray the herders onto the oil slick, right? So the goal of herders for mechanical recovery would be to make the oil, you know, 3 to 5 times thicker, right? So it should improve the ability of the disc skimmers, right? If you sprayed the herder onto the oil slick, just like you might change the ability of an oleophilic surface to contact the oil slick, but if you did that, you'd defeat the purpose of the herder in the first place. So
that's a good caveat. If herders are being applied, you would want to avoid spraying it directly onto the oil because you could impede the operation of oleophilic surfaces.
Tim, could you please repeat the name of SWA or maybe dispersant SCA you mentioned?
Oh, the name of the actual SCA that they used was Thick Slick 6535. It's on the it's in the National Contingency Plan product schedule.
All right. I know you got a shout out because they're not going to be online if you're reading these ones.
Okay, so Tim, is the UAS retrievable back to the jet ski or is it sacrificial?
yeah, so the UAS is a small little drone, right? Kind of a hobby-sized drone that can carry a camera. The idea here is that it is tethered to the jet ski, so it is powered not by its own battery. It's powered, right? These small little drones can only fly for about 20 minutes, and then you have to replace the battery. So we are using an electric cable or a tether to connect the drone to the jet ski. So it is running off the power supply from the jet ski. So it can be flying for as long as the jet ski has fuel, right? 12 hours of operation. The jet ski is built with a little hangar in it, so the drone comes down and goes into a hangar so it can be retracted or it can be deployed on the tether. The idea there is you can't go 65 miles an hour with the drone flying, right? And then it needs to be protected when you're going at that speeds, and it needs to be protected if we were to ever drop it out of an airplane, right? It would hit the water kind of hard, and drones are fragile. So yes, it is retractable back into the drone. It'll go back into its hangar. But when it is being used for aerial surveillance, it can operate for as long as we maintain fuel in the jet ski. And then it also, you know, we're doing, this is in the development phase right now, but we're looking at tethers that can go up 300 to 500 feet, right? So it can get you as high as a drone could go in the first place, based on safety concerns as well. Whether or not it needs to go that high is a question.
All right. What is the height of the tether?
You just answered that.
I'm sorry. Okay, I think that's it then for the questions online.
No, there's a couple other ones. They're just not showing up there. Like there was a question about the inshore applicability of using herders. For instance, if there was a spill near a marsh edge, could the herders be used along with some kind of water application to effectively pull the oil away from the marsh edge and move it further offshore so that other operations can take place?
So you would, so the question is, would you put herder along the marsh to keep the oil from getting into the marsh?
Well, and then it said, I think, followed up with, I don't know if you can see the text right there. Tim, I think this is one that you answered online.
Yeah, I saw it online. Yeah, so I think the question is, you got kind of a marshy area with marsh grass in it, and oil has kind of gone up against the shoreline. And how would you get it out of the shoreline into open water so you could do some kind of absorption or skimming? And so what you do is all you simply need to do is walk along the shoreline with the herder, just like Ian Hewis did in the tests that I showed the video of and that David showed the video of, right? So you would be able to move, if you put the herder on one edge, like the shoreline edge of an oil slick or sheen that has gone up into some marsh grass on a shoreline, you take the herder and you just walk the shoreline and put a small amount under the water, and it would push, you know, assuming the marsh grass wasn't, you know, meters and meters deep, it would push the oil slick out and potentially into open water, where you might be able to do something else to recover the oil. The question is whether or not, you know, a water deluge is encumbered by needing a pump and hose and that kind of thing. So whether or not you'd even need a water deluge is a question, but certainly if you got the oil away from the edge, you could use a water deluge to keep pushing it farther out.
I'll add here, the other aspect of this is it depends on how the oil got into the marsh area. If it's a wind-driven event, even though the herder may cause the oil to contract away from the shoreline, if the wind continues to blow towards the shoreline, that oil will in short order turn around and come back towards the shoreline, albeit as a thicker slick. So it depends on the environmental conditions as to whether or not you'd even want to try that.
Yeah, the herder doesn't have a lot of force, right? So a small amount of wind going the wrong way will have a significant impact on the herder's ability to move things.
Yeah, the bulk slick will still move from wind.
All right, okay, one more question in the room, and then we're gonna cut the Q&A short, or not short, we're actually over, we can continue the formal discussion.
In your future testing, could you consider adding objects into the area where the oil is being herded? Maybe objects with even texture to simulate like a swamp setting, trees. See how it behaves when it's interacting with other objects.
Well, absolutely, and that kind of is a continuation of work that has been ongoing over the last couple of years, where that sort of those sorts of obstructions have been included in some tests. They just haven't necessarily been showed in the presentation here.
If you have videos of that, that would be great to see.
I do have, but not here.
All right, with that, I'd like to thank you all and thank our guest speakers, both in person and online, for joining us, and all our online attendees and in person. Thank you very much for taking the time for this conversation. I passed around some evaluations, so if you had to, please fill them out. That's how we fill out these seminars, and also how we figure out things that we can do differently or better. So please feel free to leave them on that table or on the channel, and I can collect them later. Just one more round of applause.